Alright, guys. Alright, today we're going to actually talk about something.
Have we not been talking about something?
No, I'm not done. But I'll wait. If you guys have other conversations you need to get out, let's just get them out now. Okay, if there's some other things you guys need to talk about, go ahead and take care of it now. We have a short class and I don't want to have to stop.
No names. What? Hey, I'm gonna mess it up. If you watch this,
Are you guys done?
yeah.
Oh, okay. Okay. All right, cool. Oh no, we're not done yet. You ready? Okay. So, I didn't even really plan this. I planned to talk a little bit about studying, and then first period, it just took the whole period, and I realized it's actually kind of important. Because what's the most important thing I could teach you? Math. But the second most important thing I could probably teach you is how to study, because if you can know how to study, then not only can you apply it to math, but you could apply it to any other subject that you study here on out. And I guess I could consider myself somewhat of an expert on studying. I feel like a professional studier sometimes. So I think I have some tips that I can offer you. And all of this is not really based upon any reading, although maybe I subconsciously, I read it and I subconsciously thought I came up with it on my own. But I feel like I came up with it on my own, but then later I see study skills books, I'm like, oh, that's what I do. So I think it's proven by experience and a little bit of literature, okay? So how to study. 101, yeah. Okay, so before we even get there, I want to point out that if you guys are in AP Psych, you might know that there's two different things we could, our brain engages in cognitive processes. Okay? But we also you guys are weird. Nobody would have thought that back in the day. Okay. LOL, study LOL. Okay. I got it. You made it up. You got your own joke. Okay. This is a fancy word. I didn't learn this word until grad school when I was studying education.
What, LOL?
No! Metacognitive, okay? But metacognitive, okay. Did I already talk to you about that? I was like, Jesse remembers everything I tell him. Yes, when you think about thinking. Very good. Okay, so let's say we didn't know. Let's say some of us didn't know what this word meant. Well, you guys know what cognitive means, right?
No.
What do you think cognitive has to do with?
Together.
Thinking and
Just kidding.
your brain, right? When you're memorizing stuff, remembering, thinking, that's a cognitive process. Anything that your thinking thought process that your brain engages in, that's a cognitive process, okay? Cognitive awareness, if maybe I got in an accident and I became a vegetable, my body is still breathing, but my cognitive processes might be altered or even disabled, right? So cognition, okay? All right, but what is metacognitive? Okay, right now I'm gonna show you guys two.
It don't matter.
Let me pause this because YouTube doesn't need to know how my sixth period acts, right? You guys ready?
Yeah.
Okay. So, as I was saying, 2 strategies for vocabulary. I'm teaching you about vocabulary here. When you come across a word you don't know, which inevitably you will, for example on the SATs or any other place, there's 2 things you could do. One is you could kind of break it down into the roots, right? And you might notice that, hey, meta is a prefix that you might have seen before. It's actually from a Greek. Meta, okay? All right, that's the Greek word, meta, or a prefix. And you might relate it, so one strategy is related to other words that you know that might have the same prefix. What other words do you know that have meta in it? Metaphase, metaphor, what else? Metaphysics. Metaphysics. Do you guys know any basketball players? Meta world peace. Okay. So do any of these metas kind of make you think of anything? Not necessarily. Okay. Second strategy, okay, first strategy is related to words you know. That didn't help us that much, a little bit. But second strategy is try to think of the connotation. Do you think this is going to be a positive word or a negative word? A good word or a bad word? A strong word or a weak word? A big word or a small word? Okay, so what do you think about meta?
Thinking about itself.
Does it sound good or bad?
Good.
Sounds pretty good. Meta world peace. It's not like meta war and hunger, you know? It's like, you know, meta world peace. Okay? Do you think it sounds big or small? It sounds pretty big. Meta world peace. It's not meta, you know, point decimal or meta like crumb. It's not a meta crumb. It's meta world peace. That's a big thing. Okay? All right. Remind me to, this is a dress code for next week. Okay? But I'll wait again.
Quiet.
Okay, so we just come to the conclusion that meta is something big, something good, and it relates to metaphase, metamorphosis. If that doesn't help you, then, you know, you just kind of have to guess at that point. Okay, so meta, you're right, is metaphysics. Okay, how do you think metaphysics is different from physics?
It's about more.
So it's bigger and better? Meta better? Okay.
More complex.
To a more extent, yeah. So meta means before or above. Okay, actually the exact, and then you always have that option of like Googling nowadays, right? It's the Googleability of the word. Okay, I coined that term, by the way. Put a trademark. If you ever use that word, trademark it with Ms. Han. Googleability. Okay, so meta is something on a Greek word. Blah 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 blah. After or beyond. Okay, it's a concept which is an abstraction from another concept. Okay, so let me give you an example. Abstraction. So for example, social scientists, they do studies, right? If I was an education social scientist and I were to get a PhD in education, maybe I would go to schools and like do research projects on them. So maybe I was really interested in the impact of like racial integration on schools. So maybe I go to all the LAUSD schools and I study which schools have the most integration and how those kids perform, and I compare it to all the schools that have like no integration and everybody's the same race and how those kids perform, right? So I'm doing an analysis. And then maybe some other person, you know, in Chicago did the same thing. They did an analysis. And maybe you went to Boston and did the same thing and you did analysis, okay? So there's all these analyses going on. But maybe another social scientist doesn't want to do the ground level going into the schools and doing research. They want to do a meta-analysis by studying all the researchers and what they did and putting that into a bigger study. Do you see what I mean? So that's like a study of the study. That's a meta-analysis. Okay? So cognition is thinking. So metacognition is thinking about your thinking. How do I think?
Like a thinker.
You know, like when do I think well? What are the ways in which I think? When I think, am I just doing lower level thinking or am I doing higher level thinking? So if cognition is you just thinking, okay, that's your brain and your thoughts, okay? Yeah, thought bubble. Okay. Metacognition is you standing outside of yourself and thinking about your thinking. Oh my gosh, that is awesome. I just came up with that right now. You're thinking about you thinking. Yeah.
That's too much for me.
Okay? Okay, the blue is you.
What about thinking?
But you put yourself outside of yourself and you think about you thinking. That's metacognition. Okay? Yes. Yes. No.
So I don't think about it?
So you are thinking about it, but you're not thinking about the thoughts themselves. You're thinking about how you think about the thoughts.
What?
Okay? You get me? Okay. That's metacognition. So everything that we are talking about today has to do with your metacognitive processes. I want you guys to be more mindful of your metacognition. I want you to be more mindful of, when I learn this way, is this effective for me, or do I learn better this way? When my teacher is like this, does that help me, or do I have to do something else to supplement what my teacher's doing? Like Carla had a metacognitive moment when she said, you know what, I don't understand it if you talk abstractly. I need to see an example. Until you give me an example, I'm not even listening to you. Because she knew that metacognitively, she needs an example first. But not every teacher is going to do that. So she has to keep that in mind. Like, oh, okay, right now they're explaining it. I'm going to copy it down, but I'm not going to freak out. I'm just going to wait until they give the example, and then I'm going to go back and read what they said earlier. You see? Okay, so when you're learning, I don't want you guys to be a cog in a wheel. Okay? Have you guys heard that idiom before?
No.
A cog in the wheel. Okay, what is a cog anyway? Let me just.
Here's a bar. Yeah.
Oh, that's a cog. I totally taught the wrong thing to last grade. Okay. Okay, so a cog in a wheel is an idiom where, look, this cog doesn't have any power. All it does, look, if the red one turns, the blue one's gonna turn, right?
They're not even touching.
Like this one cranks, and so that one cranks this one, and then that one cranks this one, and then that one cranks this one. So don't be a cog in the wheel. Oh, the bell rang, so I'm going here, and the teacher did this, so I sat down and wrote it down, and then the bell rang, and I went over there, and then they did this thing, I don't know what we're learning today. Learning is happening to you. So Mr. Polgarin turned this way, so then I turned that way, and then I went to Miss Hunt, she turned this way, and then I went that way. No, don't do that. Don't be a cog in a wheel. You have to be the creator of your own destiny, even in your own learning destiny. You have to build your own connections, okay? Now let me tell you something about what I believe learning is. Again, this is one of those things I haven't really verified, although it's probably based on something I've learned. But I really believe that learning, what do you guys think learning is? Let's have a philosophical moment. What is learning? Is it just memorizing facts? Is that learning?
Being able to
interpret things? What do you think, Alexis? What is learning?
Understanding and like taking in new information.
Taking in new information, she says.
Discovering new ideas.
Discovering new ideas. Understanding. Analyzing. Discovering a new way of thinking. What? Oh. Okay, this is what I would submit to you. What is learning? I would submit that learning is the process of forming connections. Connections. Okay? To me, learning is connections. Okay? So, there's nothing to see so far. Okay, so let's say this is your brain, okay? This is, let's draw Abraham, okay? Okay, let's say he has a big brain. This is Abraham's brain, okay? Okay, so there's Abraham, okay? All right. Now, Okay, so there's all this stuff in your brain, okay? There's all this stuff in your brain, okay?
We don't have to draw this, right?
No, you don't have to draw this. Okay, so let's just say there's information in his brain because walking down the street, he heard all these things for all these 16 years. He just heard all this stuff. Do you think he's actually learned anything? It's just there because he was a cog in the wheel and he just put them there. But to me, that's not learning because if it's not connected. To me, learning starts the day you're born. And you might have learned one thing, how to breathe. And that connected to, whoa, I'm alive. Whoa, I wiggle my fingers and that I can control my fingers. Oh my gosh. Oh, I'm a person. I'm not the same person as my mama. My mama is there and I'm here and we're different. Ooh, and then I go to school and you're building, right? So you're building. Okay? Now, hold on. Miss Han comes along and says, this is really important and you're going to use it for your real world life. Radians. Random. Okay? How does that connect to anything? If it doesn't, what's going to happen to this thought? Woo! After 2 hours, it's out. Right? For example, if I come up to you and I say 오늘 집에 가서 사과 먹고 이빨 닦고 세수하고 가세요. 그러면 많이 볼 거예요, right? Okay. Let's say I just taught her. Maybe I gave her a wonderful short lesson on life. I taught her something, but was she able to connect to anything that I told her? No, right? So did she learn it? No. But what if I said, do you remember fractions? And she's like, oh yeah, I learned it in 3rd grade. Oh yeah, I remember the pizza and the pie and we did fractions. Okay, that's really similar to radians because you're just taking the fractions and you're applying and then I show you the connection, right? This radiance thing that was just floating around and ready to eject itself from Abraham's brain, all of a sudden, think of it as like a tether ball or like a radar, or like doot, 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 and it connected. Okay, so all of a sudden she learned fractions, but it's connected to radians. Okay? So it locked in. It's not a free floating agent anymore. It's locked in. And if I could lock it to something that's deeper in your psyche, if it's something that's so solid in you, because you learned fractions in your 3rd grade and you used it for all these years and it's something solid and part of your knowledge base, and I could lock it to that, that's going to become a solid part of your knowledge base.
So is this how we study?
But what if you never learned? What if you never learned fractions? Fractions was already floating like, hanging and dangling by a thread over here. And then I tried to connect radians to it. Good luck, right? That's some people in my class, They're like, but I'm just saying, it's all connected. You're a product of your history. You're either a product, by the time you get to me, you're either a product of 11 years of education or 11 years of miseducation. I'm sorry, right? Okay. You guys ready? Okay. But look, because I'm aware of this and because I know this is how learning works, I do my best when I'm teaching to help you guys form those connections, to connect to what you already know and make that relatable. So I know they say, you have to make everything relatable to kids' lives, but I'm sorry. There's only so many ways I could connect radiance to your actual life when you're going to go home today and go to, La Brea and Adams. You're not going to see radiance all the time. But if I could connect to something that's already in your brain, though, learning can still take place, right? Okay, now. If learning is connections, but not every teacher is going to build those connections for you, Who has to make those connections? You. So when you're in school, as a good student, a good learner already does this automatically without me telling you, because it's a subconscious metacognitive process that you already do. Okay? When a teacher teaches you something or gives you new information, you already try to connect it to your existing concept map of knowledge. You think, do you guys ever finding yourselves doing this? Like, wait, didn't we learn this in Miss Williams last year? Oh, wait, this is what we learned. Oh, it's the same thing. Oh, wait, but it's a little different. Wait, how is it the same as what we learned last year? And how is it different from what we learned last year?
So sometimes there's things that you just can't connect. You just have to run. Abraham.
Right? Okay, so, thank you. Now, your brain. Okay. Let me give you an example. And the computer is a great example because a computer is like your brain, to be honest. A computer contains a lot of information, does it not? Isn't it? Isn't a computer a machine that contains a lot of information, and so is your brain? So I have a question for you guys. Does your brain look like this? How many of you guys know somebody, when you go to their desktop, there's like 100 icons on their desktop. And then you try to find that one file to turn in that one essay, and you're like, where is it again?
That's how you get the Mac and look it up, man.
Okay? So my question is this. Does your brain look like this?
Yes.
Okay, where everything is all jambalaya? Or does your brain know, if I ask you, what did we learn on the second day of school? And you're like, well, miss, that was 29 days ago. Does your brain have folders?
Yeah.
Now, I'm not telling you, I mean, you can have folders physically for yourself, but but that's what you're doing with the knowledge in your brain.
Organized.
You organize it. So for me, let me just tell you about my life. I teach pre-calculus, but I also teach AP calculus. We also have a Bible club. I'm doing math department stuff. How am I going to keep all that organized?
The geometry.
Okay? Somebody says, oh, do you have the curriculum map for that one class that we did 2 months ago? If my brain looks like this, it's going to take me about 30 minutes to find that. 30 minutes I don't have that you don't have either. Yes, Chante.
Don't we already have the term folders in our brain already, because we're separated from different classes? Like, for example, you can know something from math in a literature class.
So that's what I'm saying. That's what you need to do. But see, Chante, you're like, doesn't that already happen? Because you do it, but not everybody does that. And you know what's in your brain is often very similar to what's in your backpack. If I open up your backpack, am I gonna see this? And I say, oh, where's your flip book? And you're like, oh, it's under my chemistry homework. Or is it like this? Okay? Okay, so like Chante was saying, we should have, maybe for you have a period 1 folder in your head, or you have a math folder in your head. You have a chemistry folder in your head, a history, right? You have to keep it organized. But not just that, if I just dump everything for pre-calculus in one folder, is that going to help me? No. So for me, we remember we did 4 sections so far in this chapter. So like this is what I have to organize this weekend, because that stuff, no, that can't be. I need them all to be on one of these, right? And so, and when we did section, how about we put that away? Thank you. When we did section 1, how many, do you guys remember? Those of you guys who've been paying attention, how many sections were there, subsections in section 1?
4.
How many subsections? 4. Do you guys remember what they were called?
Functions.
Inverses. Graphing one. Transformations. Okay, good. So we did linear equations, right? We did transformations. We did inverses. And this one was kind of funny. It was more transformations.
Wow.
Okay? Okay, so do you guys see how if you have it organized like this, then when you're trying to recall information, you know exactly where it is. You don't have to go into your brain, and your brain doesn't look like this. Okay? You see that? Okay, so let's go back, and I'm going to test your ability to recall. Okay, so we talked on the second day of school. Second day of school. Okay, on active reading, right? And I gave you 2 specific strategies or 2 tips. When you're reading, of course, we used the highlighter that day. Do you guys remember? I passed this out. Okay, and we highlighted this. Okay, what are 2 strategies I told you you should employ when you're actively reading? Okay, who can tell me? I have 1, 2 people. Only 2 people remember. It was only 29 school days ago. Come on, guys. Okay, let's see. Okay. How would I expect you to remember something that I told you 29 school days ago?
Write it down.
Well, some people actually took the time to write it down. So she knows where it is. And she didn't just write it down on a post-it that went in her pocket in the washing machine and ended up in oblivion. She wrote it down where she could find it. Okay? So, okay, let's see if they remember. So, William, what was one strategy?
Ask yourself questions, don't just read.
Yes, ask yourself questions. Okay? Humberto, do you remember the other one?
I do.
Do you think maybe we would remember if we weren't so busy talking?
Highlighting.
Okay, Carla, what was the other one?
It was underline or highlight important points.
That was definitely one strategy, but that's not the one I'm thinking about right now.
Would you take notes?
That is, I did mention that, you're right, but there's one specifically I'm looking for. Big picture, we definitely talked about that. What is it? Summarize. Okay?
That's what I meant by underlining.
Okay. Yeah. Okay, yeah, I kind of changed the order because, he says, why does that go first? But I was thinking about it. You have to ask questions. But if you're going to ask questions, you have to know what they're talking about first. Have you ever tried to argue with or had a conversation with somebody and they're trying to criticize what you're saying, but they're not even listening to what you're saying? They don't even know what you're trying to say and they're already arguing with you? Right? So you have to first understand what they're saying, but also be asking questions, okay?
Why they're saying it.
So, for example, okay, so let's think back. Okay, so
What is it?
and this applies to anything, it's not just math. For example, when it could be reading a website, okay? You're looking at what are they telling me? What is their main point? What are they trying to say? But you also have to be asking questions like, is this a credible source? Who is this? Is this somebody who has a PhD in math that I could trust them? Or is this Johnny's little brother, like, who doesn't know what he's talking about, right? I don't know. Or, oh, is there Johnny in here? No.
Johnny's little brother.
Oh, Kevin. Yeah, it's Kevin. Should we listen to it? Right? Also, do they have a motive? What is their motive? Are they telling me that this is the best product ever? Because, thank you. Because at the end of the link, they're going to tell me to purchase their product for $39.99? Okay?
2 payments.
Okay. So, all right. Now, so you have to summarize, and you have to, and we're gonna do this for the whole chapter, okay? So not only when you're reading, do you want to actively summarize, actively read this way, but also when you're studying. So, at the end, wow. So we came to the end of the chapter. We need to summarize. What do we learn? Let's look back. What do we learn, right? And so we want to summarize. What are some key concepts or new ideas for the whole chapter? So when we're reviewing for the whole chapter, we want to look at key concepts. When I say ask questions, make connections. So connect what we learned. Try to make it one whole. If everything we learn in this chapter looks like this, that's okay. You could probably cram it, and you know, if you have a good memory, you could probably still do well on the test, but probably not the final by the time you get to the final. But if everything from this chapter can be interrelated into a web, and if you can make connections by asking yourself, how does transformations relate to functions? How does inverses look like as a parent graph? How does exponents and radicals relate to graphs? How do radians relate to cosine? And if you could relate it, then you have more of a solid nugget of a base, and you could connect that to chapter 2 and chapter 3, and then by the time you walk out of my class, you have one web called pre-calculus, and you could lock that in to your knowledge of math, and you could link that to everything you're going to learn next year in AP calculus. Okay? Now, there's one more thing though. When you're actively reading, you just do those two things. But when you're doing a chapter review, you also need to do something called recall. Okay? Recall means, oh, remember when we did this? Oh yeah, what was that all about? Remember the paragraph toolkit? Oh yeah, I have to know asymptotes and domain and range and set notation and interval notation. Remember when we did inverse sine functions? Oh yeah, remember how we had to do factoring? Oh yeah, that's recall. But how are you going to recall if you never do, how are you going to recall?
Looking through your notes.
Yes, and you know Alexis does it, and that's why she said it. We're going to recall by looking through your, like flip through, right? Your notes, what else? What can you flip through?
Old homework.
Homework, old homework, what else? Quizzes, videos, Schoology, what else? Khan Academy, what else? What about your notebook? Miss Han, okay. What about your packets? Okay. So you have to literally go back to remind yourself, oh yeah, right? So you gotta recall, summarize the key concepts that we learned, make connections among them. And of course, one thing we should add, practice. For math, you actually have to practice your skills. I understand the concept, but when I actually get numbers and have to do problems, can I do it? Can my 3 young men please put their head up? Thank you. It's rude. I know you're tired, but I am too. Okay, please do it with your head up. Thank you. Okay, so the back of this, notice this book gives you the key ideas. How many of you guys have already noticed this? There's a list of key ideas in the back. Sometimes though, for me, I like to make my own list, and I suggest you do it, and I compare my list with their list, because sometimes my list is better than their list, or sometimes their list is better than my list. I would go through and recall and look through, flip through, and make a note, and then compare it to their list. Like, hey, I know we did radicals, exponents and radicals, and that's not on this list, so I'm going to add it to this list. Or hey, oh, I forgot function definition. I forgot that in my list. They were, so compare. So that's the key concept part. But then you have to connect them. That's the question part, and then of course recall. Okay. So we're going to do this more I want you to do this at home. You could do this with any subject. But I want you to also do this, we're going to do this in class together too, it's on Monday. But I just want to model for you guys 2 different ways that we can summarize, okay? And do all of this. So some of us are spatial thinkers, okay? And some of us are more linear, logical thinkers. And some of us are both. If you're more artistic, you might possibly be more spatial. If you're more not as and you're in a different kind of brain, if you're more logical, you might have the other one, okay? Spatial and linear logical, yeah. Yeah. Okay, some of you guys, you access the information, you see the information as a web because you like pictures, okay? So do you guys remember Khan Academy used to have this concept map of math? Do you guys remember?
Yeah.
They took it off, I don't know why. But they used to have, it didn't work maybe. They used to have like algebra, geometry, pre-calc, trig, and they used to have it all in one web, and then you could zoom in, and then they would have like more information once you zoomed in. Like the universe of math. Remember that? Okay, so that's one way you can do a concept map. So let's, like, for example, I'm just gonna sketch it in a sketchy way, like sketchy way. If we have parent graphs here, right? And then maybe, you know, you're like, oh, we also learn like radians. And then we also learn, what else do we learn? Like triangles, oblique triangles, and we learn exponents, right? And then you're like creating a web around it. So parent graphs, we learned function notation, and we learned transformations, right? For radians, we learned like degrees, conversions from degrees. We learned fractions, you know, proportions. And then for triangles, we did law of sine, law of cosine, right? SAS, oh yeah, SAS area formula, and then we did special right. Okay, now the best, I learned this in grad school, when you're making a concept map, of course you would use more space and make it prettier and all that stuff. You should actually, in the connection, you should put a verb or a sentence there. So you could just don't put an idea and link it, but put a sentence. So triangles can be solved using law of sine. Okay, or triangles, the area of which we can find by using the SAS theorem. You know, triangles sometimes are in the form of special right. You know, so if you could put a linking verb, that would be best. Okay, some of you guys like that, and that organizes information well for you and makes connections. Okay. Conversions to degrees. But some of you guys are more linear, and that's how I am. Okay, so I'm sorry if I bias this class towards that way, but that's how I think. Okay, I'm thinking more linearly. So I like to make an outline. I know Gareth taught this to you guys. Do you guys remember when you're making an outline, you start off with Roman numerals, right?
Yeah.
And after that,
Letters.
what do you have? What kind of letters?
Capital.
Capital letters.
And then lowercase.
And under that, what do you have? Arabic letter, Arabic numbers. Okay, these are Roman numerals and these are Arabic numerals. If you want to do a subheading under the numbers, what do you have?
Lowercase letters.
Lowercase letters. And if you want to do a subheading under lowercase letters, you have lowercase Roman numerals.
I use dots.
Okay? You could use bullets as well.
Dots.
After that, you can use dots, I guess. And then you could use, yeah, whatever you want. It's your system. Abed, have you guys ever used that in Microsoft Word?
Yeah.
Aquí.
Oh my god.
What? Oh yeah, then they use parentheses. Wait, why is it not working?
Right more. Oh, what the? Zoom out, man.
Ah! It stopped working. But okay, you could do it here basically. Anyway. Okay, so let's just do it real quick for this. What are some big topics we learned? Transformation, parent graphs. We learned, we kind of skipped section 2, so we did oblique triangles. We kind of did, so it was the calculator. If you just want to watch me, that's fine. Okay, oblique triangles, and then we did radians, parent graphs in unit circle. Okay, but under parent graphs, there were 4 sections, and so under paragraphs we did transformations, right? And then we did function notation, functions and inverses, right? What else did we do? By the way, this is exactly what I taught my AP Calculus students, like this week, because I realized they don't know how to do it, but they need to. And then we did linear equations. That should have come first. Okay, if I had more space, what are different types of transformations? I could put subheadings there, right? And linear equations, how many types of linear equations do we have? 2, right? We have point slope form and... So you see how, either way, you have to know how to categorize all this information in your head. So that when I ask you, what did we learn in chapter 1 and we're now in chapter 7, you're not like, what? How do you expect us to remember chapter 1? Yeah, you do. But you have to be like, oh wait, let me go back. Chapter 1, oh yeah, toolkit. Section 1, oh yeah, transformation. Okay?